Video 14 is on a topic called changing bases. We're going to do a couple things. It's going to combine the applications that we did, the word problems with the formulas 2 quizzes ago. It's going to combine that with some of the log stuff that we did on the last quiz. So if we look on this slide right here, what we have is how can we figure out a problem like log base 3 of 30? Well, if we make this equal to x and we try to loop that, we get 3 to the x equals 30. That I can't do in my head, and that's something we haven't talked about. We only have calculator buttons for log base 10 and log base e, but we can use the laws of logarithms that we used on the last quiz to be able to solve that problem. So we're going to look at that in this video. So same problem here. Let's do that loop again. It's a y this time. We're going to end up with 3 to the y equals 30. Before, we wouldn't have been able to solve that. We can't evaluate that in our head. But now we know the laws of logarithms, that if I take the log of both sides, and this is a legal algebra move because we're doing it to both sides, we can use that third law to say, well, I know this y can come down in front. So this becomes y log 3 equals log 30. So the biggest point here is when you have a variable in the exponent, by taking the log of both sides, you can get that down. And now in order to solve for y, I just need to divide both sides by the log of 3. So y equals log 30 over log 3. And if you just punch that into your calculator, you get 3.0959. So again, biggest thing, whenever there's a variable in the exponent, if you take the log of both sides of the equation, you can bring that down as the coefficient and then solve for the variable. If we look at this problem in general, and it's starting the same way, it just has a b and c instead of actual numbers. If we go through the same process, so we loop to get to this line, we recognize that the variable's in the exponent, so we take the log of both sides, move the y down in front, and then divide by log b, we end up at what's called our change of base formula. So this will save you a couple steps. Anytime you have log base b of c, you can solve that by just dividing log c divided by log b. So that'll save you some time. It's definitely the most efficient way to evaluate those, so make sure you have that down in your notes. This concept is also going to help us solve equations and eventually solve word problems. When we gave you problems like 3 to the x equals 81, we could do that in our head because 3 to the 4th was 81 and there was a nice clean answer. If I don't give you a clean answer, now we're going to need to use logs to be able to solve those. So if we look at this problem on the left, 8 to the x equals 6. We definitely can't do that in our head. We don't know 8 to the what would equal 6. But we notice that the variable is in the exponent. And again, the only way to get that down is by taking the log of both sides. So we have the log of 8 to the x equals the log of 6. I know the x can come down as a coefficient, so it becomes x log 8 equals log 6. Then when I divide both sides by log 8, we're ready to punch that into our calculator and we'll have our final answer. So x equals log 6 over log 8, which when you plug that in comes into 0.8617, and that's our final answer. Similarly, on the right, we see e to the x equals 4.5. Now x is still the variable is still in the exponent, so we still want to take the log of both sides. But since this is a base of e, we actually want to take the ln of both sides. So if I take the ln of e to the x and the ln of 4.5, what happens here is we've talked about the fact that the ln of x and e to the x are inverses of each other. So what happens there is those end up canceling out. On the left side, we're just left with x equals the ln of 4.5. So that'll save you a step. When you plug that into your calculator, you get x equals 1.5041. So that's our final answer. So problems with e to the x, if you just take the ln of both sides, it's going to save you one step. So if there's an e, taking the ln or the natural log is the best log to take. We're going to take a look at a couple quick word problems, and then that'll be it. See how this stuff comes into play here. So this has an isotope, has a half-life of 10.5 hours. How long will it take for 200 kilograms of that to decay to 35 kilograms? Once you see half-life, you should be thinking of this formula, right? A sub 0 times b to the t over k. leave ourselves some room to be able to do this and see what we can plug in. So we know we're starting with 200 kilograms. We know B is a half because it's a half-life problem. B and K go together. Remember Burger King there? So the K value is 10.5. We're looking for the T value. And we want our ending amount to be 35 kilograms. The first thing we need to do algebraically is still to divide by 200. So we get 0.175 equals 1/2 to the T over 10.5. And all that is an exponent. When I notice the variable is in the exponent, I know I need to take the log of both sides. So if we take the log of 0.175 and the log of 1/2 to the T over 10.5, I can then take the exponent by the laws of logs and bring that down in front. So I get the log of 0.175 equals T over 10.5, all of that's coming down together, times the log of 1/2. So my next move algebraically is to divide by the log of 1/2. I'm still trying to get T by itself. So if I do that on both sides, I'm going to just explain this step and not write it out. Once I solve that, once I plug this into my calculator, I'm going to have to multiply by 10.5 to get T by itself. So once you plug in the log of 0.175 divided by the log of 1/2, take that quantity and multiply by 10.5, you're going to end up with 26.4030 years. Hours. Our units are hours here. So that's going to take a little over 26 hours to decay to 35 kilograms. For this last problem, I'm taking $9,000 at an annual rate of 6% compounded continuously. And when we see continuously, we should think this formula, P times E to the RT. It's asking how long will it take for my investment to increase by 50%. So again, I'm going to give myself some room here. As we start to plug into this formula, we want to end up with 50% more than 9,000. So if we do that, that's going to be $13,500 equals 9,000 times E. We know R is 0.06 and we don't know what T is. That's what we're looking for. We want to know how long it is to happen. If you can skip computing to 13,500 and realize that we're going to end up with 1.5 times the money we start with, you can start directly on this line. But if you want to set it up using this line and divide by 9,000, you're going to get to the same place. So either way, that should work out. Since we see an E, this time we're going to take the ln of both sides. So I take the ln of 1.5 and then the ln of E to the 0.06t. And we know that ln and E undo each other since they're inverses. So we get the ln of 1.5 equals 0.06t. So dividing by 0.06, this time we're going to have years as our units, and we get 6.7578 years when you plug that in. So that's it for this section. The biggest thing, again, I know I've already said it like 6 times, anytime there's a variable in the exponent, you take the log of both sides, or in this special case, the ln of both sides, to get it down, and then you can solve for the variable.